Majority of the people do not even know how to interpret this type of graph. The order of liquefaction of different gas is that. Now the deviation from ideal gas behavior is found at low temperature and high pressure. Dalton's law of partial pressure is not applicable for this combination of gases. Hey everyone, welcome back to our channel. This is our lecture 3rd of revising chemistry under 20-minute challenge. Now, this is our third and the most important chapter, that is gaseous state. The beginning. Matter has 3 fundamental states. First one is gaseous state, second is liquid state, third one is solid state. Now, to understand about gaseous state, this all the space is known to be gaseous state. Give our first topic of this chapter, which is postulate of kinetic theory of gases. There are altogether 5 or 6 postulates that you need to remember as from the point of view of your examination. Now, first postulate states that there is no force of attraction between gas molecule. Let's suppose there is gas molecule A and gas molecule B. There is neither any kind of force of attraction between them. And we assume the mass of the gas molecule, that is mass of gas molecule A and mass of gas molecule B, as negligible. That are they are nearly close or equal to 0. Now, third one, that is the most important postulate, that is collision between the molecules are perfectly elastic. For understanding about collision which are perfectly elastic, I suggest you to watch our lecture on laws of motion. Our fourth postulate states that the effect of gravity on molecule is nearly equal to 0 or that is negligible. Now, fifth and the most important postulate is average kinetic energy of gas molecule is directly proportional to the temperature. That is, average kinetic energy of gas molecule equals 3/2 times of RT multiplied by N. N is the number of gas molecule per unit volume, where T is the absolute temperature and R is gas constant. Average kinetic energy per molecule is equals to, remove just the N from this formula. Now, what PV equals? PV equals 1/3 of mass into number of molecules into RMS velocities square. From rearranging this equation, we can simply get as VRMS equals under root of 3RT divisible by Vm, or simply under root of 3P divided by D. Now, V average equals under root of 8 times RT divided by pi multiplied by mass of the gas molecule, or V most probable equals under root of 2 times RT divided by Am. Now, for the relation between every molecule the relation between RMS speed, average speed and most probable speed is VRMS is greater than average velocity or speed, and that is greater than most probable speed. You can simply remember it as RAM, where R is greater, A is then afterward, and most probable is then afterward. Now, another thing that is important is RMS speed multiplied by 0.9 equals V average. That simply states that 90% of RMS speed equals average speed. Now, what causes the deviation of gases from ideal behavior? As we mentioned from the postulate, there is no force of attraction between the molecules. But in ideal scenarios, the molecules of real gases attract each other. And from the gas postulate, we negligible the volume of the gases, where in the ideal scenario, molecules occupy a part of volume of the room. Now, what is van der Waals equation? What is the van der Waals equation? Van der Waals equation is nothing but modified form of PV equals nRT, that is ideal gas equation, where we add pressure correction term and subtract velocity correction term. Now, what is pressure correction term? N square into A divided by V square. What is A? Velocity with respect to constant intermolecular attraction. What is B? B is executed volume, which comes under the volume correction term, that equals N times of V. Now, unit of A equals atmospheric pressure into liter square or square of liter divided by square of moles. The unit of B equals liter divided by mole inverse. Oh sorry, liter into mole inverse. Now for any real gases, vibrational energy equals, now for every real gases, vibrational energy equals kinetic energy and potential energy sum. Absolute zero. What is absolute zero, or what happens from the absolute zero temperature? Molecular motion ceases during the absolute zero. What causes the, why the deviation of gas happens from ideal behavior to real behavior? First one is low temperature, second one is high pressure. Now you can understand this ratio from this formula. Now what are gases law? They are ideal gases law. First one is Bohl's law, which was discovered by Robert Bohl during 1962 AD. It is only applicable for isothermal condition, which equals PV equals constant. That is, temperature or remaining constant, the volume of given mass of gas is inversely proportional to the volume equals constant, or you can simply remember as P is inversely proportional of volume, which gives us the graph of rectangular hyperbola. If we plot the graph, now what is Charles' law? Charles' law is applicable for isobaric condition, which simply states that for each 1 degree raise in temperature, the volume of given mass of gas increases 1 divisible by 1/73 of its volume at a 0 degree centigrade, provided that pressure remains constant. That is isobaric condition, or that simply equals that V divided by T equals constant, or V is directly proportional to T. Now there are two graphs for Charles' law, that is given as, there are two given graphs of Charles' law. Avogadro's law is we studied from 4th chapter, which simply equals that volume is directly proportional to number of molecules during isothermal and isobaric condition. Now what is ideal gas equation? That is nothing but PV equals nRT, where R equals, now ideal gas equation, PV equals nRT, where R is universal gas constant, which has the value of 8.314 in joule per Kelvin mole. Now third is rate of diffusion, or simply as Gram's law of diffusion, which simply states that under similar condition of temperature and pressure, the rate of diffusion of gas is inversely proportional to square root of density of gas, is given as that. As density is directly proportional to vapor density, then we can simply remove the term density by vapor density. As vapor density, low pressure and high temperature, real gases behave like ideal gases. Dalton's law of partial pressure. Now Dalton's law is not applicable for 3 gases condition. First, let us understand about what is Dalton's law. Dalton's law of partial pressure states that the total pressure of mixture of non-reacting gases is sum of partial pressure of the constituent gas. That is, in a mixture of non-reacting gases, the pressure of gas would exert if it were present alone in the container. It's called as partial pressure of that gas. That is not applicable for the combination of these 3 gases. Now critical temperature. The temperature above which gas liquefy is said to be critical temperature. Bohl's temperature. The temperature at which the real gases behaves like an ideal one is said to be Bohl's temperature. What is inversion temperature? The temperature below which a compressed gas on the sudden expansion into a region of lower pressure get cooled is said to be inversion temperature. The relationship between inversion temperature, Bohl's temperature and critical temperature is, inversion temperature is greater than that of Bohl's temperature, that is greater than that of critical temperature. Now the order of liquefaction of different gases is given as, now Dalton's law of partial pressure. The given expression is for the, now Dalton's law of partial pressure. This is the expression for Dalton's law of partial pressure, which simply states that the total presence of a molecule, or the total pressure of a molecule of gases which do not react, or the pressure of non-reacting gas molecules of vapor at a particular temperature, equals to the sum of partial pressure of the component of gases. That simply, energy of ideal gas is 0, but the kinetic energy is this one. We cannot calculate the absolute kinetic energy, that's why we are calculating the average kinetic energy. Now these are the most important graphs from the chapter gaseous state. If you have given something graph like this, if we are given the graph like this where we are plotted a temperature scale in x-axis and volume scale in y-axis. If we have given something like that, the upper one is lower than that of lower. That upper one is lower than that of lower one. That is, lower one is actually higher. That is, P1 is actually higher pressure than that of P2. Now, for the graph of P versus T, this volume is greater than that of this volume. As PV equals CnRT, that's why this two follows the same rule. Now, if you plot the graph for P versus T, the temperature gradually increases. That's why T3 is greater than T1. Now, if you have given something graph like that, now it is moving from 1 to 2. That simply states that the gas is heated first and then cooled. That's why the volume is getting solid for today. If you want more video, just comment below.